Now the next application of Kohlrausch law is that we can find the solubility of a sparingly soluble salt. And the third application is that we can find the degree of dissociation of a weak electrolyte. See, when we say about the weak electrolyte, suppose if I ask you, you tell me how that is what is the degree of dissociation of acetic acid. What do you say? It dissociates feebly. What we say? It dissociates feebly. But if I say what is the degree of dissociation of HCl, you say yes, it dissociates to a large extent, around 99% dissociates. You are giving some value. Can you give some value for the weak electrolyte? No. But we say the word, what I said you. What do we say? It dissociates feebly. Feebly is how much? 20%, 30%, 15%, 16%, 17%. How much? There is some value will be there or no? Isn't it? So feebly it cannot be. Some value should be there. So previously, before Kohlrausch, we were not knowing any formula by which we can calculate the degree of dissociation of a weak electrolyte. We do not know any formula, the degree of dissociation of weak electrolyte. Of course, in Ostwald dilution law, you studied in class 11, we studied Ostwald dilution law, the degree of dissociation, but there were certain limitations there in the Ostwald dilution law. Alright, there were certain limitations. I am not going to those limitations now. You know it, you have studied in chemical equilibrium. But here, we do not have any such limitations. We can calculate the degree of dissociation of any weak electrolyte like magnesium chloride, barium chloride, acetic acid, barium sulfate, silver, what you can say chloride. In this way, any weak electrolyte, we can calculate the degree of dissociation. Got it now? Because previously you used to just simply say theoretically, it dissociates feebly. It dissociates to a small extent. But how much? There should be some value. What is the value? How to calculate the degree of dissociation? Now we can calculate with the help of Kohlrausch law. What is the formula? Alpha is equal to, alpha is the degree of dissociation of weak electrolyte. Alpha is equal to cap Cm by cap infinity m. C means concentration. Means molar conductivity at a given concentration. Let us say I have given you barium chloride, I have given you, let us say barium chloride I have given, and the concentration of barium chloride is 0.01 molar. So what is C here? C is here 0.01 molar. This C is nothing but 0.01 molar. I said you know, cap Cm means what? It is simply cap M also, you can write it down. There is no difference between cap M and cap Cm. C I am writing specifically because it is a molar conductivity at a given concentration. So what is the concentration? Let us say 0.01 molar. So at 0.01 molar, what is the molar conductivity which will be given to you? And molar conductivity at infinite dilution will also be given to you. You know the formula. How? Just now I said it. Cap Cm by nu plus lambda plus nu minus lambda minus. Just now I said it. Once you know all these values, you will put it here and you will divide it, you will be getting the degree of dissociation. Now once the degree of dissociation you will get it, it is in fraction. You have to multiply into 100% to get it in percentage, because you know degree of dissociation association is calculated in terms of percentage. Degree of association or dissociation is calculated in terms of percentage. So in this way you will get the degree of dissociation in terms of percentage for a weak electrolyte. Okay, now next, after that what I said you, another that is application is that we can calculate the solubility of a sparingly soluble salt. See, sparingly soluble salt. For example, you know silver chloride, when you add it to water, it dissolves in water to a very small extent. Means if you take 1 liter of water and if you take just a pinch of, or less than that also, if you take a pinch, less than that a pinch in water, if you put it, you will find it will be soluble. Or you may find also that some part of it also will be insoluble. Got it? What I said? You take 1 liter water and you add silver chloride to it. A pinch of silver chloride. Out of that also you will see some will be remaining behind. It will not dissolve. That means what? It forms a what? Saturated solution. Isn't it? Because a saturated solution is a solution which cannot dissolve any more of the solute. Here also, it is not able to dissolve. For that reason only something is left behind. Are you able to understand or not? Here what I have added, a pinch of to it, I have added to a 1 liter of water. Out of that, little bit remains undissolved. That means what? It forms a saturated solution. Because a saturated solution is a solution which cannot dissolve any more of the solute at a given temperature. It cannot dissolve. Then only something is left behind. And moreover, the solution which I got it, the saturated solution which I got it is also a solution at infinite dilution. How? Because what I said you, 1 liter water or more than that also I can take, and a pinch of salt I have taken it, which weight is less than a gram. We can say that it can be less than a gram. So It is not an infinitely dilute solution because water is so large compared to that of the solute. The solvent is so large compared to that of the solute. Alright, then only it is considered to be as an infinitely dilute. Have you understood what I said this point? Because you need to understand the concept first, then only you will be able to understand the formula from where I am getting it. Because I said I will be taking a sparingly soluble salt. So I took silver chloride. You can take any sparingly soluble salt for barium chloride, silver chloride, magnesium chloride, barium, what you can say, this sulfate, alright, calcium sulfate, any sparingly soluble salt. Sparingly, do you understand or not? That which dissolves in water to a very small extent, negligible amount. That is what I said. Alright, so here the example I gave it to you, that you take a pinch. Out of that, when you add a pinch of salt to the water, you will see out of that still a little bit remains undissolved. That means what? It is saturated solution. And how much water you have taken? 1 liter or more than that water you have taken. And salt? A pinch. So is it not an infinitely dilute solution? Yes. So this solution which I got it is not only infinitely dilute but also it is a saturated solution. I got it. For which kind of salt? Sparingly soluble salt. Okay, fine. I hope you understood the concept. Now, here I need to calculate the solubility. Alright, I need to calculate the solubility. So here, that is kappa, that is salt, is equal to, how will I get it? Kappa saturated solution minus kappa water. Definitely. From a saturated solution, if you remove water, then what you are going to get it? Salt, na? Isn't it? Just now I said, you want AgCl. You take a saturated solution of AgCl and remove the water from it. Then what is remain? What it remains? AgCl only it remains. So understood the formula first. That kappa salt is equal to kappa saturated solution minus water. Will give you what? Kappa salt. Finished. First. Now, next is Cap M. You studied. Cap M, the formula. Cap M is equal to what is the formula you studied? That is molar conductivity. What you studied? Kappa into 1000 by M. You studied. Now here Cap M is not Cap M. Here it is molar conductivity at infinite dilution. Just now I said you. The solution which you will be taking of silver chloride, it will be infinitely dilute. Just now I said, 1 liter water or 2 liter water and you are adding a pinch of salt. So it is an infinitely dilute. So I can say instead of Cap M, I can write Cap infinitum. Done. Now kappa into 1000 by M. M is what here? M is solubility. Here M is your solubility of the salt. Solubility of the salt. Why? Because solubility is measured in molarity. M is also measured in molarity. Alright? M is also measured in molarity. So in this way, here kappa is what here? What I can say? Kappa is nothing but kappa salt. You will write it here. Not kappa simply, you will write it as kappa salt. Now it is clear. So M stands for here solubility. So what I need here, I want to measure the solubility of a sparingly soluble salt. I want M, which is solubility here. So what is the formula I will get? Kappa salt into 1000 by cap infinity M. So cap infinity M, you can break it up. Nu plus lambda plus nu minus lambda minus. This you can simplify it. Got it? Kappa salt, you will get it in this way. You will put the value, you will get the M. M is what I said? Solubility of the salt. Because solubility is also measured in terms of molarity. Alright, moles per liter. And molarity is also measured in terms of moles per liter. So instead of M, I can write it as solubility. Finished. In this way, you can calculate the solubility of sparingly soluble salt. Here, we can get it. Clear? Now, one more thing. If the solubility is asked in gram per liter, alright, if it is asked in, instead of moles per liter, it is asked in grams per liter. What you need to do? To convert mole per liter to gram per liter, what you need to do? You need to multiply with molecular weight. Whatever the answer you will get it now here, M, you multiply with molecular weight. You will be getting in gram per liter. Why? Because see, very simple. Molarity is weight by molecular weight into volume in liters. That is molarity formula. Na? So gram per liter means this is your gram per liter. See here, weight is measured in gram and volume is in liter. So I want the answer W1 by V. So what I need to do? I need to multiply molarity into molecular weight. So hence I said that if the question is asked, you will be getting this sort of numericals. That you calculate the solubility in gram per liter. Don't leave the answer in moles per liter. Convert it into gram per liter. How will you do so? Multiply with the molecular weight. See here, M into M1. So I will multiply with the molecular weight to convert it into gram per liter. Got it now? Molecular weight of what? Molecular weight of the salt. It's not mine or your molecular weight. Molecular weight of the salt, you will multiply it, you will get the answer. Solubility of the salt in gram per liter. Or if it is acts in moles per liter, leave it as it is. The answer. Alright. So in this way, these are the applications of Kohlrausch law. Thank you.